I want you to imagine a circle. I'm just going to draw part of it that has a radius r. Okay? And I'm going to pop off the radius and then slap it down around the outer edge of the circle, like that, okay? So that this distance, this arc length, is equal to r. Got it? And then the angle that's captured by taking r and laying it around the outer edge of the circle, that angle we're going to call theta. Okay? So does anybody have or know either an intuitive feel for how big theta is, or know exactly how big theta is? 45 degrees is a good guess. It's a little bigger than that. Good guess.
60.
60 is a little closer. Nobody knows exactly what it is? 60 was a tiny bit closer. Like 57 point something degrees. If this were a piece of pie, like this is an actual pie, how many of those pie pieces would you get out of that, do you think, approximately? 8's a little too many. 6 about right. 6 and maybe like a little skinny piece, like about a third of a piece. 6 and about 28/100ths of a piece. Anybody know where that number comes from?
2 pi r squared. Pi r squared.
Right. Yes, that is where that comes from. 2 pi r, 6.28, would be how many of these would fit. Does that make sense? 2 pi is the circumference, distance around. This is also, this ratio of arc length divided by radius. What number value am I going to get when I do that?
1.
1. So theta is 1 radian. That's the definition of a radian. Okay? So 1 radian is a little over 57 degrees. It's just how they're defined. Okay? Everybody fine with that? We're going to use this when going back and forth between like angular terms and linear terms. So we'll do that a little bit later. All right, now if I take theta in radians equals S over R, and I divide both sides by time, okay? What's this part of the equation? What does that give me? In the box.
1.
No, distance over time, meters per second. What is that? Yes, it's velocity. That's correct. So another way to write this is V over R, right? Everybody fine with that? I just substituted velocity in. I divided by time intentionally. And then we're going to rewrite this. This is going to be what are the units going to be here? Radians per time in seconds, right? So we have a symbol for that, and it's omega. And the units are radians per second. So I'm going to write that up here. So omega in radians per second equals V over R. Again, we're going, this is like a angular to linear conversion list. All right, so let's see. If omega equals V over R, and I divide by time again, got to do the same thing to both sides, right? If this were change in velocity over time, what would that be? You need the help of the board. Change in velocity over time is the same thing as acceleration, right. So that equals A divided by R. And then this will be radians per second, or alpha. That's what we use to describe angular acceleration. Radians per second. meters per second, okay? So alpha in radians per second squared equals A over R. And if we analyze these units, we can pick whatever one we want. Theta, for example, is radians, and that equals S over R, which is meters over meters, sorry. What happens to those units on the right side of the equation? They cancel. So radians are like mu. What are the units for mu? There are none, because it's a ratio, right? It's a stickiness ratio of how hard the surfaces are pushing together versus sliding past one another, so the units end up canceling. Same thing is actually true for radians. Radians is a ratio, that's this picture right here. Sometimes I think our advanced math kids, how many of you are in Calc AB right now? Our advanced math kids learn so much math. You probably did this like in second grade. I'm exaggerating for effect. But sometimes we lose track of the Y, right? So anytime you see radians or any of these, and if you're like doing the unit analysis and trying to put the units, right, on a test, and you end up with like, oh, everything canceled. Do not despair. You probably have what? If everything cancels, you probably have radians. You're probably solving for theta in radians. Or if like everything cancels and you have nothing per second squared, what do you probably have? Nothing per second squared. Second squared in the denominator. What's that going to be up there? Alpha. Nothing. Radians is a ratio, no units, per second squared. Like, I can't tell you how many kids have come up to me and said, I must have done something wrong. All I had is squared seconds in the denominator during a test. And I'm like, yep. So don't lose the fact that radians aren't really a unit, they're a ratio. Okay.